question number 1.20 of Kleppner-Kollenkopf, and in this question we have to sketch the motion of the particle moving in spiral path. We have to show radial acceleration is 0 when theta is 1 upon 2 radian. We have to do C part also. So in polar coordinate system, the position vector is given as this, velocity vector is given as this, and the acceleration vector is given as this. Here, the r, the magnitude of position vector is given by a theta, is given as a theta, and a is here 1 by root 2, and theta here is alpha t square divided by 2. So if I plug in the value of theta in r, so I will get a alpha t square divided by 2, and our r dot will be this will be a alpha t, and our r dot double dot will be a alpha. Similarly, my theta dot will be alpha t, and my theta double dot will be alpha. So what will be our acceleration vector? So acceleration vector will be r double dot. So I'm finding that because I need acceleration vector only in this question. So r double dot, what is our r double dot? So this is our r double dot. R double dot is a alpha minus r. This is r, and let me put this below. So r theta dot, what is r? This is a alpha t square divided by 2, and what is theta dot? This is alpha t square divided by 2, and this is r cap plus r theta double dot. R theta double dot is what is r? This is a alpha t square divided by 2, and what is theta double dot? So theta double dot will be alpha. This is a alpha t, and what is theta dot? It is alpha t. This is theta cap. If I solve all this, so I will get a alpha minus a of alpha cube t power 4 upon 2 r cap plus if I will get a here a alpha square t square divided by 4, and by solving all this I will get 5 a alpha square t power t divided by 2. Now our uh, our radial part, the radial part of the acceleration that I needed for the second part is a alpha minus a alpha square, sorry, cube, and t power 4 divided by 2. So I have to check whether a radial, what is the value of a radial when theta is 1 by root 2 for the second part. So I have to make this expression in terms of theta. So this is a alpha minus this is uh, a alpha q t power 4 divided by 2, and I can make this as a alpha minus a alpha divided by 2. Here will become alpha square t4, and I will put a alpha minus a alpha 2 alpha t square ka whole square, and I know that alpha t square is 2, so equal to theta, so alpha t square equal to 2 theta. I plug in the value of here, so a alpha by 2 into 4 of theta square, and here I will be a alpha divided by 2 into 4 theta square will be 1 by 2, 1 by root 2 square 1 by 2, it will cancel, and a alpha minus a alpha is equal to 0. So this is a radial when theta equal to 1 by root 2, it is 0. So now let us do the b part, and for b part let me write. So this is for part C. I have written the expression for AR and A theta, and I have to find when for what theta magnitude for radial acceleration and tangential acceleration are equal. So AR is just A alpha minus A alpha cube t power 4 upon 2 mod equals to what is A theta, that is 5 of A alpha square t square divided by 2. Let us take A alpha common from both sides. So this is A alpha 1 minus alpha square T4 divided by 2 equals to, here A alpha will come common, then it will be mod of, uh, mm, this will be our alpha 5 alpha t square divided by 2, and this will be okay. So a alpha will get cancelled, will factor out, and our expression will become 1 minus mod of 1 minus alpha square, sorry, alpha I can write is alpha t square divided by 2 upon 2 equals to mod of a alpha, and a alpha get cancel, so mod of 5 of alpha t square divided by 2. Now we know that alpha t square divided by 2 is equal to theta. So alpha t square equal to 2 theta. So here will become it as 1 minus. So alpha t square will be 2 theta square, which will be 4 theta square. And this is 4 theta square divided by 2. So, and this is alpha t square. And this is mod of 5 theta. Now, when our for this expression, it will become 1 minus 2 theta square ka mod equal to 5 theta. Now, as you know, I cannot just write mod x as just x, as mod x, x can have values plus x, can have value plus x when x is greater than 0, and minus x when x is less than 0. So see, if our theta is greater than 1 over root 2, then this theta square will be greater than 1 over root 2 square, uh, and this whole expression will become, this expression will become negative, this will become stay positive. So for this I have to write 1 minus 2 theta square and negative sign equal to 5 theta, as 5 theta will be positive even when theta is greater than 0. Similarly, if theta is less than 1 by root 2, so left side will be our positive always, and left right side is positive anyway if theta is less than 0 2, and it is in between. So our expression for theta will become 1 minus 2 theta square equal to 5 theta. So let me evaluate this, and this will be 2 theta square equal to 5 theta, and it will become 2 theta square, and this will become as minus 5 theta minus 1 equal to 0, and here it will become 2 theta square plus 5 theta minus 1 equal to 0. So for let us evaluate this left side, and let us evaluate this expression. So theta here will become minus of b minus b plus minus b square, that is 25, minus 4ac, that is 24 upon 2a, that is 4. And here it will also become minus 5 plus minus, and this will become 25 minus b plus minus 4ac, and this is this, and this is 4. So theta is this. Theta will become negative plus, this is 5 plus minus, and this is 33 over 4, and this is minus 5 minus root 33 over 4. So as you can see, is greater than 0. So theta cannot be negative. So I have to remove the part in which I have to cancel. I have to take only this part, because if I take minus root 33, it will become negative, and I have assumed above that theta is greater than 1 over root 2. Theta is greater than 1 over root 2, so I can take only this value, and I can take only here this value, as assume that theta is between 0 and 1 root 2, so I have to neglect the negative part, and I can take only this thing. So these are two values of theta, and which the when the particle will move in spiral path, this will again repeat those velocities, and at these angle the radial and tangential part of the velocities will be equal. Hence this is the way we can do the question.